So friends of P asked about the right-hand rule, and many of you may also have been wondering about the right-hand rule. So what could that possibly mean? So hey, let's define it. I like to define everything. So what is the right-hand rule in physics and math, for that matter? It's how to find the direction of a cross product, really. How to find the direction of a cross product and many other things. So it's really the right-hand physics, it's the right-hand rules. We use it a lot of different ways for a lot of different things. This is the first place you usually see it, is figuring out a magnetic force, because that's one of the first cross products that you see. So let's just set one up and use the right-hand rule to solve it. Again, let's have a uniform B field to the right. Let's have a charge with some charge Q and a velocity up at this time. We said the magnitude is QVB magnitudes times the sine of theta, but the direction we had to use the right-hand rule. So it's a way that you use your right hand to figure out which way the force will be. So let's go through the rules of using the right-hand rule. Rule number one is use your right hand. So here at Rice, I've had students getting everything wrong with their magnetic fields and forces, and I look at them and they're using their left hand. So use your right hand. If you don't know what I mean, here is the trick on how to find your right hand. If you do this, your fingers are making L's, and only this one is making an L, right? So the one that makes an L is your left hand. This is your right hand. And I thought this would always work, except I told it to my 10-year-old kid, and he said, no, they both make an L. And so anyway, don't do that. Like this, if you do it like this, then only this hand makes an L. So that's how to find your right hand if you're not sure where it is, okay? Use your right hand. I guarantee one of you is going to start doing it with your left hand. Promise, it always happens. Number two is point fingers along V. Well, that's not hard. There's my fingers. This is my thumb. These are my fingers. Point your fingers along V, okay? But then, it's not that simple. Turn them towards B. Turn fingers towards B. And that's when you realize it actually matters which way you have your hand, right? I can point my fingers along V this way, or this way, or this way, or this way. And I can go all the way back around. Those are all pointing along V. But then if you want to be able to curve them towards B, there's only one way they can point. And that is this way, because then they have to curve towards B. So that is V, curve towards B. And then the third rule is, or the fourth rule is that your thumb will be along F. So if we come over here for thumb along F. So if we've done this correctly, then V, if we have it turned this way across B, that way, F will be inside. And this is the right answer. For this configuration, the force will be inside. Let's do another one, just while we're going here. Now we'll do them quick, because we have our right-hand rule. B again that way. Let's have a charge Q. It doesn't have to be at 90 degrees. It can move at some angle to B, all right? So let's look at this one. It's V cross B. Fingers along V. We've got to curve them to B, and sometimes you can't do it. Your wrist is not omnidirectional. You can break your wrist trying to do this, so be very careful. Sometimes you have to get on the other side of the thing. So now I've got to walk over here and say V cross B, and that's pointing out, right? I have to have them fingers this way. This way doesn't work. It won't cross to B. This way doesn't work. It has to be V this way cross B. And you see, oh, this force, again, points out. Okay? Let's do one more. What if we have B this way, B that way, and let's make V that way, same way for our Q. V, now we need to cross it to B. Oh wait, if you get really confused and you can't figure it out, it's probably because there is no cross product. Right? If they're at the same direction, the sign is 0. V cross B is 0. There's no answer. If you get confused, you may have messed up. But if I get totally mixed up, it's because I forgot, oh, theta 0. They're the same way. So that's one way to use the right-hand rule. That's how we use it to find a magnetic field. There's another aspect of this you have to keep up with, though. For a right-hand rule to work, you must use a right-handed coordinate system. So what that means is if you think about it, when you draw a 3D Cartesian coordinate system, you have x, say, there, and you have y there. And it's sort of arbitrary which way z goes, right? I can make z go up or z go down. Well, it actually matters. If you want your right-hand rules to work and give you the right answer, positive or negative, there's a certain way it has to go. It has to be that the k hat vector has to equal the I hat vector crossed with the j hat vector. Z has to be x cross y. So if I put my fingers along I hat along x, cross them towards y, z has to be this way. That's the positive z direction, not down. So it does actually matter which way you draw z. We could also draw it like this. Here, if we put x this way, y that way, x cross y, z would have to be out if we want this to all make sense, if we want all of our cross products to come out right. We could have x going off into space this way, y going off into space that way, and x cross y, here z has to be down. Okay? So in some problems, you don't even draw a coordinate system. We just show you a piece of paper with a diagram and say which way, left, right, up, or down. And then you don't necessarily need to think about x, y, and z. But if you're setting up a complicated problem with a coordinate system, you have to actually set it up with a right-handed coordinate system. Okay? Finally, some people have a lot of trouble with this whole thing. Their wrist is stiff. They can't get it all the way around. So there's a second way to do this. Okay? Second way is this. Take your right hand. It's still the right-hand rule. And you say, you give somebody a thumbs up, I like you. And then you say, no, I'm going to shoot you. You're going to shoot them. Then you give them a little rude gesture like that. If you put your fingers like that, that will always also make a right-handed coordinate system. And you just have to remember that if you do this, that tall man is what I call that middle finger equals thumb cross index. Tall man equals thumb cross index. So if you would rather not do this version of the right-hand rule, you can just hold them like this, and you can always get it right. Because here, let's see, it would be that V cross B, V is thumb, and B is index. So tall man is the force, and there you go. V cross B, and my finger here is pointing in. Here, my thumb is V, and let's see, my thumb is V, and here's B. There you go. And then you can see tall man is pointing out, just like the force. And here, of course, there was no cross product. Okay? So that's another way to go. And if you really feel like it, you can do what I did. This is allowed. This is the one allowed cheat sheet. It is you can just write V, B, and F on your fingernail there. If you get it tattooed, I'll really be impressed. If you tattoo it on your pads, then that's an automatic A+. We also use this on campus. A very important use of this is it's the class gang symbol. Okay, so when I walk around campus, all these freshmen are they're actually fairly frightened of me. And they kind of won't make eye contact and walk away. And I feel like a freak when I walk around campus. So I told them, let's not talk. Just when you see me, we'll just sort of give each other one of these, quick right-hand rule. And then I know, okay, it's a freshman, it's a 102 student, everything's fine. And I think for the edX community, when you do the meetups, right, you're going to do a meetup, maybe you're going to go to this coffee shop. Is that an edX person or just something else? So you just kind of give them a quick one of these, and then you'll know at the edX meetup that is a 102X person. That'll help you find them. So I think it has international appeal. All right.